right, today we're going to be discussing solving systems of equations algebraically through multiplication. So this is the elimination method, except as the equations are represented, I cannot just eliminate. So I have to do one extra step, and that is to see step 3, multiply the equations through by a number that will help eliminate one of the variables. So let's get started. Solve and check each of the systems in the examples that follow. So in example 1, we have our variables set up, our equations both set up in standard form, ax plus by equals c. But if we look at each one of the coefficients, and we see a 3 and a 5 under the x, and a 7 and a 14 under with the y's, neither one of those will cancel as they are. So what I have to do is I have to go through one or both of the equations by multiplying through a number that will make one of my variables fall out. And what I'm going to choose to do is multiply through this equation by a negative 2. So what I get is negative 6x plus, minus 14y equals 24. Using a different color, I'm just going to bring this down, and I have 5x plus 14y equals negative 13. Now, when I add those two equations together, what I see is my y's will cancel out. Adding my x's, I wind up with negative x equaling 11. And I can't end on a negative, so I'm going to divide by negative 1, giving me x equals negative 11. So now I want to find the other variable. Let's find y, and I have to use one of the original equations. So I will choose 3x plus 7y equaling negative 12. I have the value of x, 3 times negative 11 plus 7y equals negative 12. Bringing the 33 to the other side by adding it, I wind up with 7y equaling a positive 21, and y equals 3. So here's my second variable, and my point is negative 11, 3. Now I have to do a check in both of the original equations. So let's do a check. And again, it has to be in the original equations. So I'll write 3x plus 7y equals negative 12. Do my substitution. Negative 33 plus 21, does that equal negative 12? And it does. So that equation checks. Let's try the other equation, which is 5x plus 14y equals negative 13. I want to check the point negative 11, 3. 5 times negative 11 plus 14 times 3. Does that equal negative 13? And looks like, yes, it does. Okay. So now I know that this point checks in both of my equations, so I'm good. Okay, let's try another one. Turn your page, and we are at example 2. And looking at my x's and my y's. The question is, which of the two variables should I eliminate? If you can eliminate one of the variables by just multiplying through one of the equations by a number, that's what you want to choose. And it looks like I'm going to multiply the second equation through by a 6. If I chose my x's, well, I could have multiplied through by a -3, but I'll choose 6. So when I multiply through, I distribute, and I get 90x plus 6y equals 288. Bring the other equation down underneath. 5x minus 6y equals 92. Adding those together, my y's cancel. I get 95x equals 380, and x equals 4. There's one of my variables. We want to find y. I'm going to go back to the original equation, substitute in 15 times 4 plus y, 60, and y equals -12. So there's the second part of the solution. I want to highlight. There's my x, there's my y, and I need to check. So let's check it. I'm going back to the original equation, checking the point for -12. 5x minus 6y equals 92. 5 times 4 minus 6 times -12. 20. Negative times a negative is a positive. 92 equals 92. That checks. Let's look at the other equation. And that is, put it over here, 15x plus y equals 48. 15 times 4 minus 12. 60 minus 12 and 48 equals 48. Check. Okay, so I would like you to try example 3 on your own. So why don't you pause here, try this on your own, and then come back. So pause the video, come back, and see if your answer matches mine. Welcome back. Okay, so let's go through this together. We're looking at our x's and our y's, and it looks like I have to multiply through both of my equations by a number to get me to a common coefficient. So what I'm going to do is multiply my first equation through by a -3, and then I'll multiply my second equation through by a +2. So let's do the first one, and we wind up with -6x minus 15y equals +3. Now I need this to be positive. 2 times 3 will give me my +6x plus 8y equals 18. Remember to distribute that 2 all the way through the end. Adding the 2 together, My x's cancel out. I wind up with negative 7y equaling 21. Y equals negative 3. Now I want to find my x, go back to the original equation, just choose one, substitute in, x equals 7. Let's check that point. I like to highlight these points so they stand out. Whoops. Oh. Let's try that again. Highlighter, highlight. Still not working. Okay, it's not liking the highlighter. That one? Okay. So my point that I'm checking is 7, negative 3. Checking that point in the original equation. 2x plus 5y equals negative 1. 2 times 7 plus 5 times negative 3. 14 minus 15. And negative 1 equals negative 1. Check. Okay, now let's check my second equation. I'll do that in a blue. 3x plus 4y equals 9. 3 times 7 plus 4 times negative 3. Does that equal 9? 21 minus 12 equals 9. 9 equals 9, so it checks. So my point, 7, negative 3, is the solution to this system. So I want you to stop at this point, and example 4 and the rest of the examples will be done in class tomorrow. Come in prepared to ask questions and to answer any WISC sheets that I might have in the tray. Have a great day.